All right, let's just jump right into this. Welcome to today's Explainer, where we're going to embark on a really unforgettable journey into one of the absolute last great frontiers of our own planet. We're diving headfirst into a pretty wild thought experiment today to explore the extreme, and I mean extreme extremes of the Earth's interior. We'll be breaking down the unbelievable physics, the immense pressures, and specifically, our main focus for today, the gravity behind planetary cores. We're going to strip away all those pesky, impossible engineering hurdles and see what actually lies thousands of kilometers beneath our feet.
So, picture this. It's kind of the ultimate hypothetical question, right? Imagine one day, humanity manages to build a machine capable of drilling a tunnel straight through the very center of our planet, all the way to the exact opposite side. What would happen if you just jumped in? Would you burn up instantly? Would you just fall forever? Would gravity completely disappear? I know, it sounds like pure science fiction, but the actual physics behind what would happen to you are absolutely fascinating.
But, well, before we start our imaginary descent, we probably need to ground ourselves in a little bit of reality. How far down have we actually gone? The current record belongs to the Kola Superdeep Borehole over in Russia. It sits at exactly 12.26 kilometers deep. After literally years of incredible engineering and just massive groundbreaking effort, 12.26 kilometers is the absolute deepest hole humanity has ever managed to drill. Now, to really put that achievement into perspective, let's compare that 12.26 kilometers to the Earth's total diameter, which is roughly 12,742 kilometers. That means after all that work, we've drilled just about 0.1% of the distance to the Earth's center. Think of it this way. If the Earth were the size of an apple, our deepest, most impressive, record-breaking hole wouldn't even pierce the skin. We have quite literally barely scratched the surface.
If we were to slice the Earth open, like a giant onion, we'd see exactly what we're up against here. First up is the crust. It's just 5 to 70 kilometers thick. This is that incredibly thin, fragile little shell where the continents, the oceans, and, well, all of us actually exist. Below that is the mantle, which makes up almost 84% of Earth's volume. It's solid rock, sure, but under all that heat and pressure, it actually flows, just super slowly over millions of years. Then things get really wild in the outer core. Solid rock is just gone, completely replaced by this vast 4,500-degree ocean of swirling molten iron and nickel. That's actually what generates our planet's magnetic field. And finally, we reach the inner core. The physics of the inner core present this truly fascinating paradox. Down there, the temperature hits a staggering 6,000 degrees Celsius. That is literally as hot as the surface of the sun. You'd fully expect everything down there to be violently liquid or even a gas, right? But surprisingly, the inner core is completely solid. Why? Well, it's because the pressure is over 3.6 million times our normal atmospheric pressure. It's so unbelievably enormous that it literally forces the iron atoms to stay locked together. It prevents them from melting, despite that insane heat. It's this epic, endless tug of war between temperature and pressure.
And that epic tug of war brings us right back to why we stopped drilling at just 12 kilometers. The Earth actively fights back against us. It uses 3 relentless enemies: heat, pressure, and rock behavior. As you go deeper, the heat gets so intense that your drill bits, even steel ones, just melt, and diamonds lose all their structural strength. Plus, the pressure ramps up to the point where every single square centimeter is dealing with millions of kilograms of force. Honestly, almost no known earthly material can survive that for long.
But the third enemy, rock behavior, this one is entirely counterintuitive. We tend to think of rock as, hard and brittle. You hit it with a hammer, it shatters. But deep underground, under all that crushing pressure and baking heat, rocks start to behave completely differently. They act more like extremely thick honey. If you try to drill a hole, the rock doesn't just sit there politely, it slowly flows. It literally squeezes the tunnel closed behind you. Your hard-earned, impossibly deep tunnel would essentially just heal itself shut. So, to actually take our journey to the center of the Earth today, we're going to have to cheat a little bit. We're going to set up a thought experiment. Imagine we have completely impossible sci-fi level technology. We've got an indestructible drill, totally unlimited energy, perfect cooling systems, and a magical tunnel that defies that honey-like rock and just stays perfectly open forever. Nothing breaks. We just drill for thousands of kilometers until we finally hit the absolute dead center of the planet. Which leads us perfectly into the core focus of our explainer today, the gravity behind planetary cores. Okay, you've reached the very center of the Earth. What actually happens to gravity down there? Do you get crushed into a tiny little point? Does it pull you in every direction at once until you tear apart? Take a second to really think about what you would actually feel at the exact dead center of a massive planetary body. The answer? Zero. Absolutely zero. At the exact center of the Earth, gravity effectively drops to zero. You would become completely weightless, just floating there, like an astronaut hanging out in deep space.
Now, this isn't because gravity just magically packs up and disappears. This is actually a perfect real-world illustration of something called Newton's shell theorem. The gravity behind planetary cores is all about the attraction between masses. When you're standing on the surface, right now, all of Earth's mass is sitting right below you, pulling you straight down. But when you're at the exact center, the mass of the Earth surrounds you equally in absolutely every direction. The gravitational pull from the miles of rock above you perfectly cancels out the pull from the rock below you. Left cancels right, front cancels back. You are locked in this perfect, delicate equilibrium of gravitational forces.
Okay, so now that we actually understand the gravity behind planetary cores, let's finally execute the jump. We have our perfectly straight, totally indestructible tunnel. We're going to ignore the extreme heat, and for just a moment, we're also going to completely ignore air resistance. You walk right up to the edge of the abyss, you take a deep breath, and you step off. At first, the gravity you're totally used to accelerates you downward. Just like jumping off a diving board, you fall faster and faster. And because there is no air resistance in this specific scenario to slow you down, your speed just keeps compounding. By the time you approach the center of the Earth, you are traveling at nearly 8 kilometers per second. That is roughly 28,000 kilometers per hour. You are literally falling faster than a lot of spacecraft travel when they're up in orbit. It's mind-blowing.
The rest of the fall essentially turns you into a massive transplanetary pendulum. Here's how it works. Step 1, you accelerate rapidly downward. Step 2, you hit that zero-gravity sweet spot at the center at absolute maximum speed, that 28,000 kilometers per hour. Step 3, as you shoot past the center and head toward the other side of the Earth, well, gravity reverses. The mass of the Earth is now mostly behind you, pulling you backward, slowing you down. Finally, step 4. This deceleration is perfectly matched to your initial acceleration. You will slow down until you come to a complete dead stop exactly at the surface on the opposite side of the world. And if no one is there to catch you, you just fall right back down, oscillating endlessly from one end of the Earth to the other.
And how long would this crazy, mind-bending, transplanetary roller coaster actually take? Roughly 42 minutes. Yep, that's the time it takes to fall all the way through the center of the Earth and pop out the surface on the complete opposite side. It's pretty wild to think that 42 minutes is basically the travel time of a short domestic airplane flight between two cities, except in this case, you're crossing the entire globe by just falling straight through it.
Okay, but I do have to be the bearer of bad news for a second here. Let's look at the harsh scientific reality. If you actually tried this without our magic thought experiment rules, that tunnel would be completely full of air. As you fall, all that air gets compressed right ahead of you. The air resistance would become utterly enormous. It creates this massive opposing force that dictates your terminal velocity. Because of that incredibly dense wall of compressed gas pushing back at you, your terminal velocity would absolutely plummet. You'd never even come close to reaching those incredible spacecraft speeds. And honestly, more brutally, you'd be dealing with 5,000-degree temperatures, splashing into molten metal, crushing atmospheric pressure, toxic gases, and the tunnel just violently collapsing in on you. In reality, survival would be completely impossible long before you even reach the mantle.
Now, some people actually worry about the idea of this entirely. There's this myth floating around that drilling a hole all the way through the Earth could somehow, I don't know, crack the planet open, cause tectonic collapse, or just completely destroy us. But that fear is entirely unfounded. Even the most incredibly massive tunnel we could ever possibly engineer would be totally microscopic compared to the true scale of the Earth. It would be exactly like poking a tiny, thin little needle through a giant watermelon. The watermelon doesn't crack or explode, right? The greatest challenge isn't damaging the Earth. The greatest challenge is simply trying to survive it.
But hey, if we ever do figure out how to survive it, maybe with, I don't know, plasma drilling or some highly advanced robotic explorers, the rewards could be just unbelievable. Get this, scientists actually estimate that the amount of gold currently sunken deep inside the Earth's core is enough to cover the entire surface of our planet in a gleaming solid layer over a foot deep. We literally know more about the surface of Mars than we do about our own core, simply because no human has ever been able to see it directly.
The center of the Earth really does remain one of the absolute greatest scientific challenges and frontiers humanity has ever imagined. The greatest mysteries out there might not just be up in the stars. They are quite literally right beneath our feet, locked securely away by gravity, immense pressure, and unimaginable heat. So I'm going to leave you with this final thought to ponder today. If that completely impossible, indestructible tunnel through the Earth actually existed, would you dare jump into it? Let us know what you think. Thanks for joining me on this explainer. And as always, keep learning.